We have two triangles. One that is a right triangle, but we are not given any side lengths. And then we have this triangle over here, which is not a right triangle. Now, if it's not a right triangle, we still know that it's going to add up to 180. So we could figure out these angles if we wanted to. We just have to take 180 minus 70. And because it happens to be isosceles, and you know it's isosceles because it's got 10 here and 10 here, so these two sides are the same. That means these two angles have to be the same. So we could go 180 minus 70, which is 110, and divide that by 2 to get that each angle is 55 degrees. But does that help us? By the way, if it is not a right triangle, you cannot use SOHCAHTOA to figure this out. SOHCAHTOA only works for right-angled triangles. So if it's not a right-angled triangle, then how do we deal with this? If you were watching the lessons, you would remember that there is a hack we can do where we literally divide this triangle down the middle in order to make a right triangle. So if you wanted to pull this out, and this is an important technique, once you start putting triangles inside of triangles, you should pull them out so you can actually see them properly. So we have 55 degrees here. We have 10 here. And then this is going to be half of 70. So this is going to be 35 degrees right there. Well, at this point, keeping in mind that ultimately we want to find x, we can probably find half of it. So we'll call the half of it. We'll call this z just for the time being. So this is z. And so we can label this. It depends on which angle you want to stand on. You can do it either way, but I'm just going to stand here. So then this would be the opposite over the adjacent. Oh, no, this is the hypotenuse. So then we're looking at SOHCAHTOA. We're going to pick sine of 35 degrees is equal to the opposite over the hypotenuse. And then we can multiply both sides by 10 to get z by itself. So z is equal to 10 sine 35, which in your calculator should come out to 7.00. So because this is not my final answer, I'm going to remind you all to keep 4 decimal places. And then we have x is going to be double that. So then x is equal to 14.0042. And again, do keep 4 decimal places until the very end. So we have this one, 14.0042. So at this point, it's actually not too bad because then you can choose either of these angles to try and figure out why. So if I'm standing here, then this is the adjacent and this is the hypotenuse. So then I'm looking at cos of 32 degrees is equal to x over y. But we know what x is. It's 14.0042 divided by y. So this does get a little bit ugly because y is in the bottom. So you all groan and you remember you have an extra step to try and get y in the top. That'll allow me to cancel out my y's. And then I'm going to have to divide both sides by cos 32. So y is equal to 14.0042 divided by cos 32. And I'm getting 16.5. Now, because they have given it to me in whole numbers, I'm going to give it to them as 17. So this one's 17, and then this one's going to be 14. And those are my two answers. So whenever you see a triangle inside of a triangle, you want to split the triangle and draw the separate pieces. So this is 70 degrees, and this is 119. Okay. And then you have another right triangle, the big one. This one here. And even though it shares a side length, 119, this one is 26 degrees down here. Now I know that you guys have another triangle here, this one right here. It's not a right triangle though. So in Trig, in grade 10 Trig, the non-right triangles tend to be not very useful to us. You can't really use SOHCAHTOA on them. So we're just trying to look for right triangles to try and figure this out, to help us out. Another thing you need to keep in mind is that even though we're only asked to find x, sometimes we have to find things in between. And sometimes those things are not labeled. And you have to give them names so that you can work with them. So maybe I'm going to call this H for the nice big hypotenuse, and that one's over here. Um, and maybe I'm going to call this B for the base. I don't know. Just this one right here. And I guess I should give a name to this one down here. I'm just going to call this Y. It doesn't really matter what you call it. But Y actually goes all the way across, right? So once we have names for things, it becomes a lot easier for you to see what we might do in this case. So the student suggested that we use SOHCAHTOA to find Y. And now SOHCAHTOA is allowed because this is a right triangle. So if this is adjacent and this is the opposite, and we don't really care about H right now. So you have to be strategic. Just because you labeled it doesn't mean you have to find it. We can see that Y is going to be more useful because if we can find Y, we can find B, we can minus them to get X. So we're going to find Y first. So opposite and adjacent, that means I'm going to use tan. So tan of 26 degrees is opposite 119 over adjacent. So if you are fast with the algebra, eventually you're going to isolate Y and you're going to have 119 over tan 26. I just skipped a few steps, but you should be able to do this by now. Divided by tan 26. And I'm getting 243. And I'm going to keep the 4 decimal places because I'm not done with it. All right. So next we're going to find B, this one over here. And again, this is SOHCAHTOA. So if I'm going to use adjacent and opposite, then I guess I'm using tan. So tan of 70 is opposite over adjacent. Oh, B's in the bottom again. That sucks. That's okay. I can deal with that. But if you're good at isolating, you'll realize you're going to have this over tan 70. So 119 divided by tan 70, and I'm getting 43.3125 if I round it correctly. So the last step is to find X. So I just need to take Y minus B. So I'm going to take 243.9862, and I'm going to subtract B. So 243.9862. I'll subtract my answer, and I am getting 201 as my final answer. And I rounded that because they rounded it to the nearest whole, so I'll give it to them to the nearest whole. So we are being asked to find X in this case. I know that these two triangles look like they are congruent, this one and this one, but it doesn't say they're congruent, so you cannot assume that this one is 39 degrees as well. They look the same, but you can't assume that. So the first thing I'm going to go around and do is I'm just going to label some of the sides, the ones that we don't know yet, and you can just tell me so that the students can tell me which ones they intend to find. I guess I'll call this one H since it's a hypotenuse. The plan is we are going to find Y first. Because once we know Y, we can subtract it from 19. And then we know Z. And once we know Z, we can find X. So what about H? Well, we don't really care about H because it's not going to help us. So we're not going to find that one. We're going to find Y first. So let's label this thing. So we have adjacent and we have opposite. So I guess we're using tan. So tan of 39 degrees is opposite over adjacent, 11 over Y. Y is going to be 11 over tan 39. So I'm getting to 4 decimal places, 13.5839. So then we can find Z because Z is just 19 minus that. So if I take 19 minus 13, I'm going to get 5.4161. 5.4161. Now I can find X. Or can I? I don't have any angles. So how do I find X if I don't have any angles in this triangle? In order to find X, the easiest way is to use Pythagorean because we have this And we have this. So to find x squared, you're going to have 11 squared plus 5.4161 squared. So I'll square that, add it to 11 squared, and I'm going to get 150-ish, but then I have to take the square root. So I'll take the square root of that, and x is going to be 12.26, but they're giving me whole numbers, so I'm going to give them 12. So x is equal to 12. Do not forget that Pythagorean is a tool you have in your pocket, and you can use that. Some students wanted to actually use the inverse to find this angle, which you could do. You'd end up with still the right thing, but it's an extra step. In this example, we are asked to find x. But as we have learned before, it is sometimes helpful to label the sides that you don't know so that maybe you can talk about them, think about them, and maybe find some of them. So we do know that this one's 14, that one's 16, that's x, and this one is 10. Josh says, we're going to do this first. This blue triangle here. And I guess it would be helpful then to call this Z. So just for the sake of clearing this up in your mind, here's the blue triangle. Here's Z on the bottom. Here's 10. Here's 16. And he says, let's just use Pythagorean. So Z squared plus 10 squared is equal to 16 squared. So then you have to isolate for Z. So we're going to take 16 squared minus 10 squared, and then we're going to square root it. You guys should be able to do that with your eyes closed. So Z I'm getting is 12.48. Actually 4900. So next step, we want to take a look and see that there is another triangle here. And let me warn you, please do draw that triangle separately so that your numbers don't get mixed up. So here is the red triangle. I should do a little bit better. So then this is 14, this is 10, and this is y. So same sort of deal. Y squared plus 10 squared is equal to 14 squared, and we can isolate for y. So 14 squared minus 10 squared, and then I'll square root that to get y is 9.797, actually 80. So then lastly, to find z, or sorry, we already found z. We're looking for x, that's what we're after. So we're going to get x is equal to z minus y. So you're going to take this and you're going to minus that. So 12.48 minus 9.798, and I'm getting x is 2.682. But I guess they are rounding it to the nearest whole number, so I'm going to say x is 3, and that'll be my final answer. So we have a shop, and we're ordering a sign for the roof. So we have a couple angle of elevations here, which we covered yesterday. If you look at the bottom, here's our angle of elevation. If you look at the top of the sign, here's our angle of elevation. But they want to know how tall is the sign. So actually, they want to know this piece over here. This is our x right there. So this double triangle is very difficult to look at. I'm going to separate them out into a small triangle and then a bigger one. So I'm going to color code this. So the smaller triangle is here, and it's got 31 degrees here. 31 degrees. And it's 24 feet on the bottom. That's the shorter one. And then the taller one is 42 degrees, but it's also 24 feet on the bottom. And so we have two of these side lengths here. I guess I can call this y, and I can call this one z. Students want to find y first. It's opposite over adjacent. So we're looking at tan. So tan of 31 is y over 24. So y is 24, tan of 31. I'm going to show you a little bit of a hack here. I'm not going to type that in. I'm just going to find z. So z, similar idea, opposite over adjacent. So tan 42 is equal to z over 24. So that means that z is equal to 24 tan of 42. Let me show you how it's done in university. These are exact values right now. They're not rounded or anything. I know that ultimately, in the end, I'm just going to minus these in order to get x. I'm going to take the long one, z minus y. So I know that this is z minus y. So instead of typing this in my calculator, I'm just going to string it all together. So I'm going to go 24 tan 42. And then I'm going to subtract 24 tan 31. And that's the only time I will type into my calculator. And that way I don't actually lose any accuracy because these are in exact values. And I don't have to type so many digits. So 24 tan 42. Make sure you close your brackets on the tan 42. 24 tan bracket 42, close bracket. And then minus 24 tan 31 in brackets. And if you do that, and your calculator is very good because you have a graphing calculator, then you will come out with the exact value. And it says to the nearest tenth of a foot, so I'm getting 7.2 feet, which is this one right here. So if you want to do it the way the pros do and you have a good graphing calculator, you can just keep your expressions. You don't even have to type them in early, and then at the end you can just kind of string them all together in your calculator. But you don't have to. Usually if you round to 4 decimal places, that's going to be good enough. But this is just much more slick and you don't lose any accuracy.